Okay, welcome back to Unit 4. This is our last lesson, lesson number 5. And ultimately, we're going to be doing some word problems with this and understanding what we're asked to solve for these different quadratics. But basically, we're going to be either completing the square or using the quadratic equation. So let's just kind of write down when we use these methods. So the first one that we learned here was called completing the square. So to complete the square, and we basically use this method of completing the square when we want to turn standard form into vertex form. And why do we want it in vertex form? What's useful in vertex form? Well, usually the question is going to be asking me for the max or min value. So what it's asking me for, when it's asking me for max or min, is ultimately the vertex. So is it asking me for the lowest point, which is the vertex, if the parabola is pointed up, or is it asking me for the highest point if the parabola is pointed down, which is the vertex? So anytime I see max or min, think, you know what I have to do? Complete the square. The next type of questions that I can have is when it asks me to either solve for the quadratic, or it asks me when does the quadratic, or when does the function, or the whatever it is, the rocket, when, or the ball, when does it hit the ground? If it's asking me for the ground of that parabola, when it's asking me for the ground, is actually the x-axis. So it's probably asking me for, or it is asking me for, the x-intercepts. And if it's asking me for the x-intercepts, that means I want you to, we could use that method of factoring. But honestly, right now, in this unit, it's going to be the quadratic equation. That quadratic equation gives me when it hits the ground. So it gives me those zeros. So these are the two type of questions that I'm going to have. Max or min, or when it hits the ground. And when it hits the ground is going to be the quadratic equation. Max or min is going to be completing the square. So let's look at the first example over here. Gives me the quadratic equation, and it's given to me in standard form, and then go figure, it asks me for the max or min, and then it says when does that value occur. So basically it's asking me for the vertex. In order to solve for the vertex, what do we need to do? We need to complete the square. So what we're going to be doing is completing the square with the first one here. For completing the square, remember, these are going to be my steps. So I'm going to write out the equation first here. Your first step is to put brackets around the first two terms. Forget about the last term. And you're going to factor out whatever this a value is in the front. I don't care what it is. Remember when I was saying that? So you're not factoring out an x. Leave the x's. It's just the number, and it's coming out of the first two terms. And it doesn't matter what that number is. If it produces a fraction, cool, doesn't matter. That 2 has to come out. When that 2 comes out and goes in the front, you're going to be left with x squared minus 6x plus 11. Nothing happens to the 11. What happened to the 12? You divided it by 2. Now, the next step that you're going to do is you're going to take the middle term, and you're going to do two things to it. The first thing is you're going to divide it by 2. 6 divided by 2 is 3. The second thing that you're going to do is put it to the power of 2, or you're going to square it. 3 to the power of 2 is 9. You're going to add and subtract a 9 into the equation, and what we're doing is making a perfect square. So now we've got 2 bracket x squared minus 6x plus 9 minus 9 plus 11. Now, do you remember which one of these 9s has to come out? That's right. It's a negative 9. In order for it to come out, to be with that 11, you have to multiply it by the 2 that's in front, or the gatekeeper that's in front of the bracket. So now you're going to be left with 2 bracket x squared minus 6x plus 9. Negative 9 times 2 is negative 18 plus 11. Now we're going to simply group the negative 18 and 11 together. We're going to square root the first and last term and take the sign of the sum. And then we'll be done. So the 2 doesn't go anywhere. It's my a value. There it is. The square root of x squared is x. The sign of the sum is negative. The square root of 9 is 3. Bracket, put that to the power of 2. Remember that power of 2 because it's a quadratic. And then negative 18 plus 11 is negative 7. So now I have this vertex. And when I take this 3 out, remember it's always going to be the opposite. So positive 3 and negative 7. This is my h and my k, which is my x and my y. So now it's asking me, what is the max or min value? Well, what I've got here is I've got a minimum. How do I know that I have a minimum? Well, I've got a positive a and a positive a. So if you have to sketch it out, positives point up. And this vertex right now is at 3 and negative 7. So the minimum, to answer this question here, what am I dealing with, a min or max? The minimum is negative 7, and that negative 7 occurs, so when does this value occur? At 3. So I have a min at negative 7 at 3 whatever. 3 seconds, 3 minutes, 3 hours. And that's ultimately what I'm dealing with for completing the square and those type of questions that ask you for the max or min and when it occurs. Now let's look at the next type of question here. It looks like a word problem. All we're going to be looking for is some key words in here to determine whether I'm going to be using the quadratic equation or completing the square. So let's read it. A glass works that makes lead crystal bowls has a daily production cost C in dollars given by the relationship, and then it's got that quadratic equation. B is the number of bowls. How many bowls can be made to minimize the production cost? What is the cost when these bowls are made? So see this word right here, minimize? We know right now what we're dealing with. We're dealing with a completing the square. It's not asking me when do these bowls hit the ground or anything like that. So what I'm going to be doing is the same thing that I did above. You can actually try to complete the square for this one. Actually pause the video now and then we'll go through it in a second. So now that you've tried to complete the square, hopefully you can look at what I've done here and you can see that it's the same as yours. So what we did was we wrote down the equation, put brackets around the first two terms, right? So that 0.2 and that 10. I'm going to take that 0.2 out. So that means I'm going to divide that 10 by 0.2. So now the 0.2's on the outside. We're going to take that 10 and divide it by 2. So now it's 50. And then that 650 at the end, nothing's happening to it, right? Nothing's going to happen to it at the end until you add it. So then we're going to take that 50 divided by 2. 50 divided by 2 is 25. 25 to the power of 2 ends up being 625. And now we're going to add that 625 in and subtract that 625. Again, the 650 at the end, nothing's going to happen to it. So we're just going to keep it there all the way to the end. And now we're going to take that negative 625 out. The way that we're going to take that out is multiply by whatever's in front, which is a decimal. Cool, it doesn't matter. It had to come out at the beginning because that's our rule to make a perfect square. Once it comes out, negative 625 times 0.2 is negative 125. Then we'll perform our last steps here by collecting the negative 25 and the 650 together. That's 525. Then we'll do the process of completing with our perfect squares of factoring them. So the square root of b squared is b. Sign of the sum is negative. We'll write negative. Square root of 625, 25 squared. So now we've got our quadratic written from standard form into vertex form, and this means stuff, and it's always going to mean the exact same thing here. So what we're looking at is the vertex. When I take this h out, it's going to be 25, and this k is 525. Now what it was asking me for was the price of the bowls and how many bowls are made to minimize the production costs. So now by looking at this, we're going to see that the price of the bowls ends up being $25, and that the number of bowls that I can make is 525. So this is always going to be my price and my quantity because it's going to be the max and when that max or that min occurs at. So this is the actual max or min. So I can make or produce 525 at what cost or when that occurs. This is always the when that occurs. So it's at $25. For this last question here, it's ultimately asking me the same thing to complete the square. It's saying Jeff throws a ball vertically upwards from the top of a cliff. The height of the ball above the base can be given by the following formula. find the maximum height, and how long does it take for that ball to reach the maximum height. So this is looking for my K and my H value from my vertex, which is going to be my method of completing this square. So I want you to try that on your own right now to complete the square for this question, because it's a pretty straightforward question. There's nothing to it. And I also want you to maybe try something else with this question too. Let's practice, let's change it up. Instead of completing the square too, you're going to try that, and then you'll look at the solution page for that answer. I want you to also try to find out, when does it hit the ground? When it hits the ground, because this could be a good question to practice that, is going to be using the quadratic formula. So I want you to practice using the quadratic formula, which we've done multiple times in this lesson, for this question, and tell me when the ball hits the ground. What are the two zeros? You should be getting a negative time and a positive time, and I want you to use the positive time for how long it takes, because negative time doesn't exist, as we've talked about before. So I also want you to check the solutions page in Google Classroom to find out the quadratic equation and what the solutions are for that. Number 4, we're not doing because we're only doing the overall expectations.